Welcome to Brain Vision.
Question 120 is a weak acid calculation, most specifically a weak polyprotic acid. And you also need to understand the 5% rule. We have three different polyprotic weak acids with different Ka1 and Ka2 values. Although this is not completely correct, it is the only method that you would know how to do having read this chapter. You really need to solve this system of equilibria simultaneously, meaning you would solve for the one hydronium concentration that is produced from both Ka1 and Ka2 simultaneously. But because that concept was not introduced in this chapter, then we are going to make the assumption that each equilibrium occurs in series and not simultaneously in parallel. So if we have the first Ka value, Ka1, we are referring to H2A reacting with water, making HA minus and some hydronium. Then we will assume a subsequent equilibrium is HA minus reacting with water, making A2 minus and its contribution of hydronium. So what we can do is solve for the hydronium concentration by having it equal the square root of Ka1, 1.0 times 10 to the minus 4, multiplied by the concentration of 0.1 molar, and we get 3.16 times 10 to the negative 3 molar. That's the hydronium concentration, but it's also the HA minus concentration that we will assume is the concentration before the subsequent Ka2 equilibrium occurs. So now we can solve for the hydronium concentration for the second equilibrium by having the hydronium concentration be equal to the square root of its Ka2 value multiplied by the concentration of HA minus that came from the first equilibrium. And we get 3.97 times 10 to the minus 4. Now for the 5% rule. If this contribution is less than 5% of this contribution, then the second contribution can be neglected. So we'll take this contribution divided by this contribution, multiplied by 100 to get a percentage, and we get a percentage of 12.6%. We then do the same thing with different Ka values. A Ka value of 1 times 10 to the negative 4. They're all 1 times 10 to the negative 4 for Ka1. So we get the same concentration here, but now the Ka2 value is 1 times 10 to the negative 5 instead of 5 times 10 to the negative 5. This gives us the second hydronium contribution of 1.78 times 10 to the negative 4. When we calculate its percentage, we get 5.63%. That's still not less than 5%, so we still can't neglect this second contribution. But for the last one, again, Ka1 is 1.0 times 10 to the negative 4. We get this same amount from the first contribution. This then ends up being the concentration of HA minus in the second contribution, where the Ka2 value is 1.0 times 10 to the negative 6. And we get this as our second contribution to the hydronium concentration. We divide that by the first contribution, multiplied by 100, and in this case we do get something less than 5%, 1.79%. So it is only with the last scenario we can neglect the second step.